in programming, but I've heard other voices from beginners before that functional programming actually is easier to learn for beginners than the regular way that programmers learn coding. So maybe, and I hope, I haven't seen the slides yet, maybe his presentation will give us all a bit more light how we can use functional programming for work and why it's useful. Thank you, Jeremiah. He has been here a few times before, and we're glad to have you here. So switching over to Jeremiah, give him a few minutes, and he can get his applause when he introduces himself.
Yeah, we're going to try and cook up some pretty good code today, so hence the pictures. I hope you will understand why in a little while. I'm talking about functional programming for web developers. And a little bit about me first. My name is Jeremiah, but a lot of my Japanese friends call me Jerry. It's a little easier. I'm from a tiny southern African country called Malawi. And I'm a computer science student at Doshisha University in Kyoto. I love to code in my spare time when I'm not doing machine learning and all that. Actually, my research is in speech synthesis. I'm working on a speech synthesis system for my native language, which is Chichewa, which is the first of its kind. And I love, well, my development background is in PHP. I've been working in PHP for close to 5 years now. I'm not very proud of the language, but I will say that things have gotten better in PHP land, thanks to things like Composer and nice frameworks like Laravel, which I highly recommend. I'm learning JavaScript. I did, as a web developer, you kind of sort of do jQuery as, even though you don't know what you're trying to manipulate, but I'm going back to the basics and learning JavaScript and trying to understand how it works behind the scenes. And I'm also learning C#. I think it's going to be a very, very interesting language for 2017. I love rap music, video games, football. I'm an Arsenal fan. And I actually do some graphic designing. For those that don't know where Malawi is, that's right there. It's also called the warm heart of Africa. And that's our beautiful flag. Anyway, functional programming. By the way, you can ask questions if you follow that link. So we can try to keep it interactive. Where do we begin? Well, no better place than to show some code. Now, I hope this is legible. I hope you can read it. Try to squeeze, but maybe that proves my point. This is a JavaScript program that is trying to find a right-angled triangle whose sides are less than 10 and whose perimeter is 24. And as you can see, it's actually a very simple program. I have an empty array there, triangle, and then I try to see if C is less than 10, and then while I'm in that loop, I start another loop for B, make sure that it's less than or equal to C. While I'm in that loop, I start another loop for A, and then in the final loop, I have my condition to see if C squared is A squared plus B squared, right? And then also if the sides add up to 24, and if I get it, then I push it to my empty array over there, and I will have hopefully all the arrays which meet that condition, all the sides which meet that condition, and as you can see, 6, 8, 10, that particular array gives me those sides that meet that condition. The same sort of task in Haskell. As you can see, actually that first line which says let right triangles, you could write it as one line. I've just sort of demarcated it so that it makes a little bit more sense. Thanks to some interesting programming paradigms in a functional language like Haskell, we could do very, I think, more readable things like these, right? List comprehension in this case, where we take a particular list and then we give it its conditions right within the definition. In this case, we're looking for a tuple that has 3 things, and where C is less than the range 1 to 10, and B is less than the range 1 to C, and A is less than the range 1 to B, and A squared plus B squared is C squared, and A plus B plus C is 24. So if you're going to explain that to someone who probably doesn't know programming, well, they can sort of understand what's going on, even though they're not familiar with the syntax. And then we get the exact same answer. So that just, I felt, was a good way to just give us all an overview of what functional programming is by comparing it with its equivalent code that is imperative. Now, Wikipedia says that functional programming is a programming paradigm, style of building the structure and elements of computer programs that treats computation as the evaluation of mathematical functions and avoids changing states and mutable data. That's Wikipedia. I say that it's an old style of programming where the program is a composition of functions that feed other functions with no side effects. Now, why is it old? Actually, functional programming is becoming something of a buzzword today. You know, you see it on Medium, you see it in blogs and YouTube. It's actually been there since at least 1958. You know, it's actually pretty, if I'm not mistaken, it's probably older than object-oriented programming. And like everything else in fashion, we human beings like to go back into history and see how things were done back then and see if we can bring it back. We get bored easily. I kind of look at functional programming as an electric car versus a petrol-driven car, right? I mean, you've got the Tesla now that's sexy and cool, but actually in history, electric cars were there before petroleum cars. So, but it's a style of programming more than anything. It really is a way of thinking that, as Martin said, for some that probably are just getting into programming, introduced to that style of thinking, it might seem easier because it reads just like you would read a mathematical equation, or you would read what you're trying to do to your data, versus another style of programming where you're going to try and model your system around things or objects that are in real life, hence object-oriented programming, right? So with that, talking about object-oriented programming, when you learn it, obviously you're told about the building blocks, encapsulation, inheritance, polymorphism, and I'm trying to see if I can find the same for functional programming. There's a lot of things that are worth wrapping our heads around, but I've tried to, within the period of time I have, to squeeze some of what I think are the more important features of a functional program versus maybe an imperative or an object-oriented program. And firstly, I would say that function purity is something that I feel is very important to understand. And that's that functions should only operate on what is given to them without manipulating the world around them. So this is an example of an impure function. There's somewhere in the world there's a total variable that is set to 0, and we do this all the time when we're trying to come up with a sum. And this is the ES6 notation, which says that, well, I want you to return sort of a total. You know, I want you to add to the previous total. So if the total was 5, then the new total should be 5 plus what you give it, right? And then you can see in that function definition, you're just giving it the number, and yet you're asking it to work on a total that you didn't give it. So it has to go out in the world and look for what total is. And that in functional programming is a definite no-no. That's an impure function. We want pure functions that, like in below here, you specifically say, listen, I'm giving you a number and I'm giving you a total, and I want you to work within the realms of what I've given you. And it gets a little bit tricky when you're coming from a world where you've got void, main, printf, all these things that are working on outside things. And then you come to functional programming and you think, well, how am I supposed to do anything if I can't work on the outside world? But I think that's the beauty of it, the ability to think outside the normal way in which at least I've been taught to program. Another important, I think, feature of functional programming is this immutability. The state should not be changed. When we assign a variable to a value, it should always remain value forever. Well, obviously not forever, for as long as the function scope, that particular scope, is alive. And you see that with the let keyword now in, I think, the new JavaScript definition. I'm sorry, my contrast here is not very good. We're testing the the variable that's inside the function. So the first function takes, we assign a variable, we assign the value 1 to x, and then we say it's true, which we return true, and then we make x is equal to 2, and that means that we're changing what x originally was, and then if we log that to our console, we'll get that 2, and then if we get out of that if sort of scope, then we log, we get 2, which can be confusing and has been the source of a lot of bugs and musings over the years when you're working with variables, right? You don't know, I could set a name variable to Jeremiah, and then I could go home, and then I don't know, maybe I could sleep walk or something, and then go to my computer and change the variable, and then tomorrow I don't know what my name is, isn't it? Well, that's very highly unlikely, but just to then that scope, and then as we go to true, it lets x equals 2. Now this is not the same scope, therefore x equals 2 is a different variable. So if you print that, you will get your 2, but if you get out of that scope and print x, you will get a 1 because we haven't changed the state. So that's a very, I think, important, simple, but a very important feature of a functional program. Another thing that I think is important, the last thing I want to talk about, is this idea of abstraction. We hear it all the time, and sometimes it can take a little bit of getting your head around to understand this whole idea of a higher order function. And basically what it is, it's a function that can take other functions as arguments or return other functions, which allows us to create an abstraction of what the function actually does. If you look here, I've got a list of numbers, and I have created a sort of function that sums up these numbers, and I initiate it to total. I'm sure we've all done this before, and I go through the for loop and everything, and then basically what I do is I take the total, and then I keep adding to what it was until I get the final total, and I log it out and I get my answer. And this is how maybe 6 months ago, maybe a year ago, how I'd have gone about this, perfectly fine, perfectly readable, I think, and why are we even talking about functional programming? Anyway, and then my boss comes up later and says, you know what, I want you to come up with a product of those numbers. You came up with the sum is great, but I want the product. So I say, okay, fine, that's easy, right? I'm just gonna go make another function and call it product, and then I'm gonna this time set the initial value to 1 because I don't want to start with 0, right? Because it would just keep multiplying times 0. And then at the end of the day, I get into my for loop again, and then I give you a total equals the total times the whatever is in that list at that time. And then I return and I give you the product. And nothing wrong with this, right? Again, easy peasy, get the job done. Everybody understands what's going on. But if you look closely, you start to see that the two functions are almost exactly identical. All of that code that I've written, I've had to write it over again. And the only parts that are changing here is a definition of the function. I've changed it from sum to product. The initial value, first was 0, now I've changed it to 1. And then what I'm doing inside there. So there's a lot of boilerplate code here. And it's cool if you're doing 1 or 2 functions, but if I want to do the same over and over again, then the risk of making a mistake as I duplicate my code becomes more and more. And also the ability to change the code if there needs to be something done also becomes greater, because if I've got all this, these functions going on all over my code base, and now the world decides that to add something we use another operator, not the add, then I have to go to all of my code base and like remove that add symbol with maybe, I don't know what the next, maybe an emoji. So it doesn't seem to be a problem now, but as we go on, it is a recipe for disaster. So what do? I am going to basically say, okay, let me abstract out some of this boilerplate code. Let me take it out so that we don't have to think about these things, because we're doing them over and over again. Let the code work for me. I shouldn't work for the code, right? And so what I do is I define a function called do something, right? It just does something. It's an abstraction. And I give it the list that I want that something to be done on. I give it the something that I want to do. And I also give it an initial value. And this time I set it to a default of 0. But I could always like override it and put whatever initial value I want. And then everything else remains the same. We don't need to go into details about how a for loop works. But the total here, in this case, this is an oversimplification. But the total here, all I'm saying is do something with the particular list and the previous total and append it to your total, right? And then what I do is that something is actually a function. So within this function definition, I'm passing another function, and I've defined that function at the top there. I want to multiply, right? So my multiplication function is just defined as take two numbers and return the product of those two numbers. And so if I pass that function into here, into this something place, then I can, I've created a higher order function here, a very simple higher order function where this function, this do something function, takes another function and then does something and then returns. So at the bottom there, I should have really had it highlighted. I could just say do something and then the list and then the function that I want, which is multiply, and then I get the answer. So I don't have to repeat myself. And then, as you know, how the example is probably going to go, my boss is going to ring me up again and say, hey, listen, why don't you come up with an average of those numbers in your list? And because I've got this do something function, I can say, oh, great, I will do it right now over the phone. You don't need to hang up. So what I'll do is I'll just simply inline what I need to be done. I've got my do something, I've got my list, and then I will just give it that function, which takes an item and a total, and then it just returns item divided by the length of the list plus the total, and then that will give me my average of that particular list without having to write all that boilerplate code over and over again. So this is just a very simple idea of higher order functions, and there are loads of them in functional programming, because functional programming teaches us to think of what we want to do to data, not how. So the first thing that when somebody says, hey, get this piece of data and give me the average, the natural way of thinking is not to start with for I is equal to 0. That's how we've been trained with imperative languages to think, but that's not natural. The natural way of thinking is data, do something, get the average. Transform, mutate, do something to the data. And I think functional programming, one of the greatest advantages is just that ability to give us a different way of thinking, especially if you're coming from a heavily imperative background. And there are lots of actions that we can do that a lot of functional programming languages come with. Out of the box, you've got your head, tail, and it. So I could get a list, and I could just say, okay, I want the head of that list, the first element in that list, and a functional programming language will give me that. I want the length. We use this all the time. in JavaScript. I want the maximum, the minimum of a list. These are inbuilt in most functional programming languages. I want to reverse the list. And actually the way it does these is using higher order functions and recursion. There's no loops in a pure functional program. There's no while, there's no for statements, and everything is done recursively, because with a for loop or a while loop, remember we keep mutating that I, that iterator. But with a functional programming language, we're not mutating anything. If you define a function today, you come back after 50 years, you can be God sure that function will work the same way that you defined it. You can't do that with an imperative function. You don't know what's going to happen in 50 years. So these are some of the actions that we can do to list out of the box. It helps us to think of these lists that way, right? Actually, I didn't have to write the sum or product. It's something that I could have just used the functional inbuilt sum and product in a functional language, right? And then I just want to give a special mention, a special shout out to these three sort of building blocks. Every functional programmer has these in his toolbox, and that's a map, reduce, filter. And we could go on for minutes, maybe 30 minutes explaining what it is, but this is explained in a single tweet. And I like this very much because it just captures the whole thing, right? So a map function takes, the original array that you give it, and then you do something to it. You transform that array, and what it does, goes through each element in that array or that list, and then does that action that you told it to do on each one of those elements, and gives you a list of transformed things. So as you can see, you've got some corn, you've got a cow, and you've got a chicken in your list. And then if you tell it to cook, what it'll do, it'll go through that list and come up with maybe cornmeal or cooked corn and a hamburger and an egg. You've done a specific constant action on each one of those particular elements, right? And then the filter, what it does is, I want to get just what is vegetarian. And so it will get the first, it hasn't been highlighted there because it is assumed that it's carried over from the previous. So it will get the corn and it will get the egg, and I've got my vegetarian. And it will leave out the beef. And then I've got a reduce here. Now what a reduce does is it goes through each and every array, or each and every element in your list, and sort of does something, comes to the next one, and uses what it did in the previous one to do something on that particular one. And then, so at the end of it, this is also called a fold in other functions. And I think a fold is a better, I like the word fold, because what it tells me is if I've got an array, with different indexes, what I can do is I can fold it one by one until I get one little card. It's compressed, it's folded, and that's what a reduce does. So if I reduce all of that stuff, the corn, and the cow and the chicken, at the end of the day, I will do some work on it, and I will have one output, and yeah. So why should we care as developers? That's a good question, and here I would like to. I don't have time to go through like a proper demonstration, but just to explain, I was trying to work on this earlier, but just to explain, as web developers, we're always working with data. Whether you're a back-end developer, you're working on an API that sort of produces data, and you're a front-end developer, you're working on consuming that API and presenting it in a specific way. We're always working with data. And so I think functional programming is important because it allows us to treat that data as a first-class citizen of our application, not to treat a for loop as a first-class citizen of our application or a query. But we want to do things to data, right? And it helps us to reason about that data because users want data presented in different specific ways. And I think learning to the paradigms and functional programming helps us to sort of reason about that data in a more natural way. And just very quickly, I'm just going to go to my pen here. I've got this. I was working on this in the train as I was coming here, so it's I wish it was more complete. But anyway, this is a list of you know, just a simple database of. Let me see if I can. And like employees, right? And then basically what I want is, my boss wants me to present, you know, she's very interested to know what the gender gap is between male and female in terms of the pay, you know, like who gets to earn more. And this is just randomly generated. So we want to see if randomly generated data is biased towards paying more females or paying more males, right? So that's what she wants, and that's how I want to present it on my app or my website. And so naturally or imperatively, I would look at this and I would think, oh, okay, great. Let's get some gender salaries, right, from the data. So I initiate an empty array of male employee salaries and female employee salaries, and then I do my for loop, and then through each one of those employees, and if the employee gender is male, then I push the employee's salary into the male employee salaries. You get what's going on, right? And then after that, I will try and what do I do next? I'm going to sort these salaries. So I'm going to create sorted males, and then I'm going to take the you know, male employee salaries and sort them from largest to smallest. And then, oh, by the way, my boss says she just wants to compare three sort of people to see the highest earning three people, and to see, you know, what they are between male and female. So I'm going to sort these males, sort the females as well. Not important what the code is doing here. And then I'm going to take the first three salaries of the sorted lists, again, for loop. And after that, I get my first three males, first three females, and then I'm going to put them in an object which says top earners from an imperatively derived. And there we go. I've got my comparison, and if I sort of console log that, what I have is my top earners imperative. There we go. So I've got my three females, and actually it looks like the females are doing pretty well in my virtual database. And I've got my three males. So my boss is happy, right? Now let's think of how probably we could have done it functionally, right? So all the way down here is something equivalent to what I'm trying to get using reduce. It's actually not complete. What this will give me is, let's see what that does. Let's comment out that console log. And let's see what that does. So what this piece of code right here, this var, this top earners functional, what is done already is to give me an object of males and females. It's not sorted, and it's not the top three. That's what's remaining to be done. That's what I couldn't complete before I got off the train. But my guess is I'm probably going to need to map it, and then each element, each sort of in my object, I've got female and I've got male. So the female and the male, each one of them I'm going to sort, and then I'm going to have a sorted list, and I could do more transformations. But the idea here is that I am taking my, this is a reduce function, and I am taking my employees, that, you know, the database, and I am reducing it, but to reduce it I have to give it a function, and with that function I have to give it my sort of total earners, right? And then also the current employee that recursion is currently on. And so I can also initiate the initial value. This comes as you learn about what reduce does. And then the initial value, I give it an object that's got female and male, and the female has a empty array and male has an empty array. So that's the initial value. So what I do is, as I go through, remember what it was doing is it was going through the cow, the corn, the and whatever it was, the chicken, and then with each case it would compress them and do something until I got one output, right? That's exactly what I'm doing with employees. I'm going through each employee one by one, and as I go through each employee, I'm taking the value that was provided from the previous earners, which is originally given as none for female and none for male, and then what I'm doing is I'm just sort of pushing it into the into that particular into that female. I'm pushing the employee salary for female. So I'm checking if the gender is female, and if it is, then I'm pushing that particular employee salary to the female part of my my object, and that's what it's doing very simply, and that's just I mean, for me to have achieved that obviously the imperative is also doing a sorting, but for me to have achieved that, I had to do a lot of things that were necessary in the original part. But here, and it's not necessarily just the amount of code that's reduced, but it's the readability. I'm looking at my data is first in my functional program here. It's first class citizen. What am I doing to the employee? I'm reducing, right? And that's how I reason about it. And after that, I can compose it to another transformer. And that's why I say my idea is I'm going to put a map on top of this, or I'm going to connect it to a map transformation, and it's going to give me something completely different. So you've got these small moving parts that make up your functional programs that are easier to think about as a web developer, that